we'll have to figure out some way to get the recording over to you. I assume it'll be a pretty big file, so.
Just do it through Dropbox is probably the easiest.
Okay. And Jeff, what I was going to do was I was planning on running through, we have a FlowCon presentation that we typically, the sales engineers at Sporlan will give to, contractors and wholesalers. That should probably take about an hour to run through. Then I was going to run through the two main catalogs, the 611H catalog, as well as the parts kit catalog, just to familiarize everybody with the two documents. And then after that, I guess we can hit on whatever you wanted to touch base on as well.
I think that'll be a great start there, Eric. And actually, the staff has already had those digital copies emailed out to them.
Okay, great. And then Mike Pod, can you? I know I sent you the list. I was just thinking about this morning. We have a pretty substantial list of all the CRN numbers. So it'd probably benefit everybody to have that. So Mike, I sent that to you. Would you be able to send that off to all the key people that would need that with RSL?
Yep, I can do that. I've got that.
Yeah, according to Mike, we actually have a pretty extensive CRN list, right, Mike?
Correct. Yeah.
So yeah, RS has done a pretty good job of maintaining that over the years. Jeff, let me know when you want me to start. I don't know if you want me to give a few minutes for everybody to join or.
I would say go ahead. We're at 10 o'clock and I'm going to start by saying thank you to everybody for showing up and attending, and Eric, most especially, for giving your time to do this presentation for us.
Thank you very much. First of all, can you guys all see my screen with the 4 FlowCon valves on the front?
Yes, we can.
Okay. All right, so just want to start off by thanking everybody for joining. My name is Eric McClure. I'm one of the regional sales managers for the Sporlan division of Parker. Just a little background about me. Before I came on to Parker, I used to be a design engineer. I was designing chillers for several years out of college. And then about 4 years into that, I ended up joining the Sporlan division of Parker back in 2007 as a sales engineer. And then 2010, took over the Chicago sales office, and then did that for about 7 years. And then in 2017, I actually jumped over from the Sporlan division over to the refrigerating specialties division and oversaw their sales force for both the FlowCon and the industrial side of the business as well. And then in beginning of 2019, I believe it was, we decided to merge the Sporlan division and the RS division into one big division. Kind of kept the two separate still, and we still do. We still have two separate sales forces, two separate customer service departments, two separate plants as well. So what I oversee now is I still oversee the industrial side of the business and the FlowCon side of the business. And then I also oversee the Sporlan traditional side of the business for the northern half of the US. So I've been with Parker for about 14 years now. And like I said, I've kind of learned both sides of the business, both on the commercial and the industrial side of the business. So as far as contacts, Jeff, I sent you a contact list with all the pertinent contact information for the Broadview location. It has, Joan Hawthorne's name, or the contact information for sending orders in, which is rsd_orders@parker.com. The main phone number there, which is where you can contact either customer service or the applications team. We have two main people on the applications team, Jeff Teplin and Juanita Gutierrez. And like I said, Joan Hawthorne is the customer service manager that oversees the customer service team for RS. And then Mike Pod will be your main sales contact for the RS product, both the FlowCon and the industrial side of the business. I assume you all know who Mike Pod is. Mike, you've been probably calling on them for how many years now?
About 17.
Okay.
Coming up indirectly. I mean, between Doug Fieldhouse and Jen and Rolf, we've all covered them. But 17 years with Sportland now.
Good deal. So that's kind of a little bit about me. Let me know if you have any questions about my background. Like I said, what I'm going to do is I'm going to first jump into this is a typical presentation that we put together. Jeff Teplin, our main applications engineer, put this together several years ago, and this is one of the presentations we use when we do training for contractors and our distribution channels as well. So this is solely focused on FlowCon. Down the road, we can definitely tailor some other trainings, more focused on the industrial side of the business. I'll probably have Jeff Teplin join us for that, since he has extensive knowledge background. He's been with Parker RS for, I think, 42 years now. So he's got a extensive background knowledge on the industrial side. But for today, this is mainly focused on the FlowCon product. Feel free to stop me if you guys have any questions or any comments. So I'm just going to kind of jump into it. The presentation's geared towards pressure regulating valves, obviously the FlowCon product. And let me just jump right in here. So can you guys see, just want to make sure I'm in the presenter mode. You guys can see the FlowCon regulators, 3/8 at 2 5/8 port.
Yes, we can.
Okay. All right, so I'm just going to go through the different types of valves that FlowCon has. Obviously, we have inlet regulating valves, outlet regulating valves, differential regulating valves. We have valves of all three of those natures with automatic electric shutoff. These are used for temperature control, for the suction line for EPR applications, pressure limiting valves, whether it's a crankcase pressure regulating valve or limiting pressure into the receiver. We also have, head pressure control valves for condenser holdback valves, as well as differential valves. So here's the typical applications that are covered by FlowCon. You got your crankcase pressure regulating valves. So, and I'll go through the nomenclature in this presentation, as well as I'll show to you where it's at in the catalog. But we basically, for the most part, use similar nomenclature to what Sportland uses. We use an O for an outlet pressure regulator. We use an E for an external equalizer. Sport valves are, the S in sport stands for the solenoid shutoff valve. ORT stands for open on rise of inlet. So it kind of uses the same nomenclature as what Sportland uses. Sportland obviously it has the SORD valves and the ORD valves and the CROT valves. So very similar to the Sportland. Obviously at one point the RS side competed against Sportland until Parker bought Sportland, and then we kind of had two similar product lines. The FlowCon product line's a lot larger of capacities than the Sportland product line, but we still do maintain both product lines. So just going down the list here, you got crankcase pressure regulating valves, which are your A8 series of valves, and they're outlet pressure regulating valves. You also have your discharge regulating valves, which are the differential valves. The L stands for differential. The O stands for outlet regulator. And then we also have our smaller series valves, which is the A9 valves. And I'll dive more into detail with these later on. But the A9 valves are smaller outlet regulating valves that are typically used for hot gas bypass or receiver pressurization applications. And then finally, we got the sport series of valves, they're also based off the A8 platform, but they're geared towards evaporator EPR control. And so you have your ports without the solenoid shutoff feature. You got your sports, which do have the solenoid shutoff feature. And then we'll dive into this more in a little bit, but the sport 2s, which is your aluminum bronze bodied sport valves. So stop me if you guys have any questions. So some of this you probably already know, obviously, but it might be repeat of what you already know, but feel free to ask any questions. So obviously inlet regulating valves, some of the other names used for inlet regulating valves are evaporator pressure regulating valves, a holdback valve, whether it's an evaporator holdback valve or a condenser holdback valve, head pressure control valves, upstream regulators, back pressure regulators, and relief regulators. Jumping over to the outlet side of the valve types, you got your receiver pressurization regulators, you got your hot gas bypass regulators, your reverse acting regulators, crankcase pressure regulating valves, and downstream regulators. All these are just the same terminology for a valve that looks at downstream pressure and controls based on that. And then you got your differential regulators. You got your discharge regulator and you got your receiver pressurization regulator. They could be looking at the difference between your condenser inlet pressure and your pressure going into the receiver and tries to control based on that. Kind of like you guys are probably familiar with the ORD valves from Sporlan. Those are differential regulators, or the LDR valves also from Sporlan. Those are differential regulating valves as well. All right, so jumping into this. So first we're going to go over the sport type valves. So like I said, you got the sports and you got the sport twos, and the S that's in parentheses, that stands for whether or not the valve has a suction shutoff coil. They can shut the valve off whenever it's energized. So you can either get the valves with or without the suction shutoff feature. Like I said before, the Sport 2 valves are aluminum bronze bodied valve. They are, more corrosion resistant than the standard sport valves that have a painted body. So these aluminum bronze Sport 2 valves have an aluminum bronze body and an aluminum bronze cartridge. It's also got a stainless steel piston and parabolic plug. The bonnet assembly is made of aluminum. Pretty much everything's corrosion resistant. So that's the advantage. That's why a lot of people use these, and that's why we offer these for the sport valves, is because they're in the suction line where there's a lot of condensation. So it prevents corrosion in the suction line valves. So that's the Sport 2s, and then the sport valves are the ductile iron bodies. They're made of a ductile iron. The body and the cartridge are both made of ductile iron. It's painted. One thing I do want to update you guys on was we're working on a project to bring in a new paint line into our Mauston, Wisconsin facility. We're looking at doing a higher end powder coat paint for all of our valves, not just Flowcon valves, but also the RS industrial valves. One of the complaints we've heard in the past, obviously, and it's rightfully so, is our paint, especially in suction line applications or in industrial applications on top of rooftops, it doesn't hold up as well as plating the valves. So we offer plated valves on the industrial side, but we're also working on improving our paint line and bringing an entire new paint line into the Mauston facility. And the powder coat paint we're using is a similar type of powder coat paint that's used on compressors. And so we've tested this powder coat paint well above 500-hour salt spray. So it's actually competes and actually has exceeded the valves that are out there that are plated valves. So that's just an update on one of the things we're working with at Mauston, is we're working on upgrading our paint line. But back to the presentation. So the sport valves are the aluminum or the ductile iron body and cartridge type valves. They are a little bit less expensive than the Sport 2 valves, since the Sport 2s are obviously made from aluminum bronze body and the cartridge. They are a little more expensive. Also, the sport valves, they range from 3/8 inch port size and connection size all the way up to 2 5/8 inch port size and connection size. Whereas the Sport 2 valves, they go from 3/8 up to 1 3/8. So if you have any applications where you need 1 5/8, 2 1/8, or 2 5/8, you have to go with the sport valves. Up through 1 3/8, the Sport 2s are available. And here's kind of what shows it right here, actually. So the Sport 2 3/8 up through 1 3/8 port size, and the sport valves are 3/8 through 2 5/8 port. So there's 4 main components. You guys are all familiar with the Q valves and the BQ valves from Sporlan, where you can kind of mix and match and build your own valves. And so you got your body, your capacity cartridge, and your power element. So on the sport valves, they're very similar. We've actually toyed around with the idea in the past of building a Flowcon bench, if you will. And, people could stock the bodies, the capacity cartridges, the adapter assemblies, and bonnet kits, and kind of build up their own valves. I know, some wholesalers do stock all the different components, and they'll mix and match. They'll take a capacity cartridge off of one valve and put on another valve in order to make the valve that the customer needs. That's what they do now. But it's a very interchangeable valve. You know, you got 4 different components. You got the body, which, you know, you can, there's on the sport valves, there's 2 different size bodies. On the A8 valves, there's 3 different body sizes. And that's where you have your inlet connection, your outlet connection. And based on the port size, that's where you get into the different body sizes. And then the capacity cartridge, you are able to swap those things in and out. So say you got a Sport 2 5/8 valve on the shelf, and the customer comes in and he needs a 7/8. You could always take a 7/8 capacity cartridge and swap it out with the 5/8 that's on the valve now, and you could take that 5/8 port size valve and make it into a 7/8 port size valve. The only thing you can't do is you can't jump from one body size to another. So you couldn't take a 5/8 valve port size and throw an 1 5/8 capacity cartridge on that. It just wouldn't fit with the body and the rest of the valve. But that's one of the ways it's very interchangeable. So the capacity cartridge obviously determines the capacity of the valve. And then the adapter assembly is what determines the functionality of the valve. So you could have an adapter assembly that's geared towards inlet regulating products, outlet regulating, differential. Specifically for the sport valves, this is where the suction shutoff feature comes into play. So if you just had an adapter assembly that did not have any solenoid coils on it, that would be considered a port valve, not a sport valve. And then once you have one coil on there, that's a sport valve where you have a suction shutoff feature. And then if you have 2 coils on there, that's the Sport B, the shutoff valve that has the shutoff feature as well as the wide open feature. So that's typically used on applications that have like dual temperature applications in supermarkets where you control one temperature based on the control of the valve, and then the second temperature would be forcing the valve wide open so that case pulls down to rack pressure. So so the Sport Bs is where you get into it, where you have 2 different application temperature controls. Dive in a little more into the separate parts of these valves. So obviously this is the body, and you either have ductile iron or aluminum bronze based on if it's a Sport or a Sport 2. On the inlet side of the valve, you have an inlet pressure fitting, access fitting, so you can read pressures on the inlet of the valve. On all the different components that stack up in these valves, there's alignment pins that allow you to basically align the different components. So as I'm gonna pull up you guys see my pointer right now?
Yes, we do.
Okay, cool. All right, so these alignment pins right here, they act as a number of features. Number one, this is where the pressure bleeds up into the valve. So like for an inlet regulating valve, this is where the pressure bleeds up into the valve and goes throughout the valve. But this is also used as an alignment pin so that the capacity cartridge can drop on top of the body and align with the body. So it's used for multiple different purposes. Obviously, we got copper fittings on all these valves. And then let's see what else here. That's pretty much all. And like I said, there's the access fitting right here on the valve as well. So
Actually, Eric, if I may interrupt for just a second, for the guys that are working with the contractors doing service, the alignment pin that Eric is referring to, quite often, well, not quite often, but often enough, a mechanic will try and put the components together wrong, and that alignment pin will get crushed. You can straighten out that pin and it will allow the valve to continue to work. You can remove that pin if you had to have that valve back in service until it can be properly repaired at a later date, as long as everything is aligned correctly for that pilot tube to go through the gasket to the next component properly.
Yep, good point. And then also, as far as the alignment pin, and this is, like I said, this is the pilot inlet stream right here. Sometimes, if a valve is failing to operate properly, this is the passageway, like I said, for the pilot pressure to come into the valve. If the contractor's working on the valve, trying to determine why it might not be controlling correctly, always check that passageway, because that could get plugged with some type of debris, a solder ball or a copper chip. So that's one of the areas you always want to make sure you check. And then we also moved this access fitting used to be, I believe it used to be, this is before my time, but I think it used to be on the capacity cartridge. And what the problem was, let me jump back here. It used to be right here. And what was happening was contractors were burning their hands on the coil when they tried to connect to the valve. So I don't know how many years ago we moved it, but we moved it down to here. So if you might come across an old valve out in the field that has the axis fitting up here, but it's since been moved down here. So, so that's the first component. The second component is the capacity cartridge. This, like I said, it determines the capacity of the valve. It can either come in aluminum bronze or ductile iron body, depending if it's a sport or a sport two. You'll start seeing all the gaskets that are involved in this valve. So you got a gasket on the bottom side of the capacity cartridge, and a gasket on the top side of the capacity cartridge as well. And so the alignment pin would slip into this passageway right here from the body. And then again, there's another alignment pin up here that aligns with the bonnet assembly. So I'm sorry, the adapter assembly. So this is what we call right here. This is the parabolic plug. It's stainless steel, and this whole piston moves up and down based on the flow of the valve, flow going through the valve. So as this piston moves downward, it opens up the passageway and refrigerant flows up through the port around the parabolic plug to the outlet. So that's kind of how the valve controls. Trying to think, one thing, I think there's a slide that touches on it later on, but there's a lock nut right here that you need to make sure. And there's directions in some of our literature on how to set this valve, but there's a lock nut that if you over tighten a lock nut, the piston doesn't move as freely as it should be. So this is a capacity cartridge. Again, like I said, all the inlet pressure bleeds up into the valve, up through the passageway, and then it bleeds into the adapter assembly, which is right here. And again, like I said, the adapter assembly is basically what determines the functionality of the valve. So you could have, if you're looking at the A8 type valves, you could have an inlet regulating adapter assembly, an outlet regulating, a differential assembly. You could have one with a shut-off feature, one with a wide open feature. So there's many different combinations that you can make out of these valves, but the adapter assembly is what determines the functionality of the valve. Also here is where, if you don't have the electric open feature on the valve, you'll have a manual open stem. So you can manually open the valve up. So if it's in the suction line, you want to manually open it up so the valve opens up to rack pressure. You can do so by opening up this valve. Again, this is the same passageway, the same bleed passageway. The alignment pin from the capacity cartridge aligns with this passageway. And then this is where the pressure bleeds up onto the bottom side of the diaphragm. And the diaphragm is basically the dividing point between the bonnet assembly where all the springs are up here and the rest of the valve. That's the dividing line. And so you'll have an O-ring on the bottom side of the diaphragm and a gasket on the top side of the diaphragm. One thing to make sure, if you're ever diagnosing a valve or you're taking apart a valve, make sure that it is convex up. So the diaphragm has a bend to it. So make sure it's convex up and it's not concave down. If you buy a replacement diaphragm kit, the diaphragm is stamped this side up on it. So just make sure you always have that thing, right side up. And then with all the gaskets and O-rings in here as well, obviously we sell gasket O-ring kits, but make sure if a contractor is diagnosing a problem, make sure the gaskets and the O-rings, there's nothing damaged with those O-rings and gaskets. There's no debris on the diaphragm either. So, but the diaphragm is basically what controls the valve. As it flexes upward and downward, it allows pressure to bleed through here and onto the top side of the piston assembly. And then,
Eric?
Yep.
Could you go back one more slide, please? Can you point to where the O-ring is on the cartridge that needs to be replaced if somebody is replacing a cartridge? Because what happens quite often, guys, is when a customer is replacing the components for a Flowcon valve, they leave the body in place. And the O-ring where Eric is pointing at this point in time, that needs to be replaced every single time. Even though they're taking the guts out of an existing body, as soon as that O-ring is in contact with oil, there is an expansion rate, and it may pinch and create a incomplete seal when they put the valve back together. More times than not, what I've found is the result of a flow-con valve not working correctly is that O-ring has been slightly pinched, allowing a bypass of the inlet pressure that comes up from below the cartridge there, or the parabolic plug there, and will not control pressure correctly for its entire lifespan until that O-ring is replaced. And there are two-part kits that you need to keep in mind for this. It's the 205017, which is for the A8A and the A8-1 body size valves, and the 205018 for the A82 size valve.
All right, thank you. You guys, I assume you've started loading a lot of the part numbers into the system, into your system as well. Jeff, I think I gave you the Excel spreadsheet, correct, with all the part numbers and descriptions and list pricing.
Yes, Greg Hardevelt, our purchaser, has loaded the majority of it into the system, and we're going to continue to review it as to what we need to do.
Okay, great. Yeah, that Excel spreadsheet's very handy. I mean, we have our PDF price sheets that breaks it down by product category, and it's a little more, detailed. But the Excel spreadsheet's an easy way if you want to look up a specific part number real quick. So, all right. So going over, so this next slide. So this slide shows, this is a typical example of what you call a port valve or an A8 valve with no shutoff feature. You see there's no solenoid coil on it. So it doesn't have the shutoff feature. Now this is the adapter assembly where it does have one solenoid valve. So it's an electric shutoff feature. So when the coil is energized, it's regulating. And then whenever you de-energize the coil, the valve goes and shuts down. So if you're doing like a reverse gas defrost application and you're checking around the EPR valve, you would shut the valve off, shut the coil off, the valve would close, and then you would reverse gas defrost flow around this EPR valve back into the evaporator. Again, you still have the manual open stem in this feature as well, but this allows you to do an electric shut off as well. And one of the things I don't know if Jeff, maybe this be beneficial. I don't know if I haven't already sent this to you, but I created, maybe 2 years ago, I created a file and I can update it as well. I ran a report showing all of I ran a report for all of our rack OEMs, what they've purchased as far as Flowcon valves over the past 3 years, I think it was. And I basically ranked them based on most quantity down to least quantity so that you're able to take a look at that and see, okay, this is what the OEMs are using most, and and base purchases off of that. So that might be beneficial if I haven't already sent that to you.
No, we don't have it, and yes, I can forward that on to purchasing. That would be a help.
Okay, yeah, I was thinking about that because you don't see too many port valves being used in applications. For the most part, we sell a sport valve variation. So, and then here is the sport valve with the B feature. It's the wide open feature basically. So you got two solenoid coils on the adapter assembly. The one on the right is still your electric shut off. So if you're energized, you're regulating. If you're de-energized, you're shut off. And then you got your second coil on here, which forces the valve wide open. And so if you're energized, you're wide open. And if you're de-energized, you're regulating. So in order to go into wide open mode, you'd have to have both coils energized. And again, that's typically used if you have a dual temperature case. You're controlling, one temperature to say 20 degrees Fahrenheit, and then, say around Thanksgiving, you want to convert that case to a turkey freezer. You then, energize the bypass coil, and then you pull the system down to rack pressure, and then you run at a lower temperature. So, all right. Just here's another breakdown of the operation of those two coils. So on the shutoff coil, if you're energized, you're regulating the flow of refrigerant. If you're de-energized, you have the valve completely shut off and it's not regulating refrigerant. And then on the bypass feature, if your coil is energized, you're wide open. And if your coil is de-energized, you're in the regulating feature. So feel free to ask any questions if you have any questions. And then the final part of the 4 parts that go into any sport valve or A8 valve is the bonnet assembly. And this is basically where you adjust the setting of the valve. So on the sport valves, because they're on the low side of the system, you only have 1 spring inside of this bonnet assembly. Whereas whenever I show you the A8 valves for the high side of the system, you'll see 2 springs in here because it's controlling a higher pressure. The bonnet assembly is made of aluminum. It's got a stainless steel adjusting stem, a lock nut. It's got, there's an O-ring seal right here. So the diaphragm that sits on top of the adapter assembly is right here in red. And then you've got your, I call it a pin carrier, but you got your, the bottom part, your spring carrier basically with your O-ring seal around here. And so in this application, no refrigerant should be up in this bonnet assembly. Whereas when I show you guys the differential valves will have refrigerant up in this bonnet assembly. So this O-ring seals any refrigerant off from getting up into here. And then obviously as you adjust this adjustment stem downward, you increase the pressure. And in our catalog, it does show that, you know, for how many turns, how much pressure differential, how much pressure change you get based on each turn. So, yeah, so basically that's the sport valves. And like I said, you use the adapter assemblies to use the adjustment stem on top of the bonnet assembly to change the pressure setting of the valve. And then this just goes into some information as far as, you know, different types of pistons and the parabolic plugs, just all the features of the sport valve and why it's able to control such precise pressures on the suction line. So this is just showing some tests that we've run in our lab. So in Broadview, I don't know if you guys are fully familiar with the RS division, but we have 2 locations. We have outside of Chicago, which is what I work out of, is the Broadview facility. That's where all of our sales, engineering, marketing, supply chains based out of. And we have a lab in Broadview. And so we have an ammonia lab in Broadview. We're actually looking to move. We also have a CO2 lab that we're looking to move to Broadview as well. We're going to pretty much make the Broadview facility the natural refrigerants location. And then down at Sporlan headquarters, that's where we do all of our testing on the other refrigerants, the HFCs. So we've done a lot of testing on the Flowcon valves down at Sporlan headquarters as well too. So, and then up in Wisconsin, in Mauston, Wisconsin is where our production facility is at. So Mauston's, if you haven't been up there yet, Mauston's about, I'd say an hour and a half north of Madison, Wisconsin, and about 2.5 hours outside of Milwaukee, Wisconsin. So we'll have to get you guys down to the facility at some point in the future once we're allowed to travel again. So this kind of just shows the parabolic plug feature. The reason why the control that we use is a parabolic shape versus just a linear pin shape is so that we can get quick opening. So as the valve opens, as the pressures increase, the valve will open quickly. So it reacts to changing conditions, changing loads, and then it flattens out. Whereas if you just had like a pin shape or a flat pin, you'd have more of a linear flow. So that's why we've done this. Same concept as if you've ever taken apart like a Sporlan expansion valve or a Sporlan CDS valve. It has a parabolic plug shape like that as well too. So here is so the nomenclature for the sport valves and sport 2. So again, I'd say, hey, Mike Pod, I think it was Sporlan came out the sword valves before Parker came out the sport valves, right?
Correct.
All right.
Yes.
So Parker technically copied off of Sporlan and kind of used the same nomenclature for the most part. You know, for Sporlan, you got the SOAR. It's S stands for electric shut off. O or I stands for open on rise of temperature, and then T stands for the inlet pressure tap. So Parker kind of did the same thing back in the days. They did S for electric shut off again, P for Parker, O for open on rise of inlet, and then T for pressure tap. So this is your typical nomenclature. You know, you either have a port valve with no electric shutoff or a sport valve, which has electric shutoff. And then if there's a 2 here, that means it's the sport 2, which has the aluminum bronze body. And then if there's a B there, that means you have that second solenoid coil that allows you for wide open feature. And then we operate an 1/8 of an inch, both on the sport valves as well as the A8s and the A9s. So a sport 711 means you've got a 7/8 port size and an 1 3/8 or 11/8 connection size. So you can mix and match the different connection sizes and port sizes within the same body size. So right here kind of shows you the 2 different body sizes down here. You got the smaller body size for the sport valves, which allows you to go from 3/8 to an 1 3/8 port size. And then you got the larger body sizes that allow you to go from 1 5 to 2 5/8. And again, these larger sizes are only available in the sports, not the sport 2 valves. And then you also can, mix and match your connection sizes as well within those body sizes. So, any questions on the nomenclature? And I'll show this again. I'll show you guys where this is at in the catalog, the 611H catalog also. But does anybody have any questions at all? I saw there's one chat. What is Class F solenoid coil? So Class F is the type of solenoid coil. I believe it, and I have to double check. I believe it corresponds to the temperature rating of the coil. So I believe we have Class F and Class H coils. I'll have to double check on that for you, but I think we have a Class H coil also. It's a higher temperature rated coil.
The Class H is used on the S6B, Eric.
Okay. Yep. And I thought I'd have to double check. I thought we also offered a H coil. I might be wrong, but I thought we offered an H coil for the Flowcon as well. But you're probably correct. So, all right. Go to the next slide. So CVs, I don't have the CVs listed on this presentation, but I can send you the CV list of all the valves, not just Flowcon, but I can also send you the RS side of the product line as well. But we obviously have a wide range of CVs for all these different valves. So, and we actually have a table that shows the CVs of the sport valves and how they compare to Sorit valves and CDS valves as well. So you can compare them to the Sporlan mechanical valves as well as the Sporlan electronic EPR valves also. Here's just a snapshot of parts of the lab that we have. Again, once we're allowed to travel, hopefully we're allowed to travel here in the near future. But feel free, we can set up a time whenever some of you guys might want to travel down to the Mausam, Wisconsin facility or the Broadview, Illinois facility, which is where I work out of. The Broadview facility again is where the lab's located at. And here is a snapshot of the CVs. Like I said, we have a table I can send you guys that actually has the CVs listed of all the, not just the sports and the sport 2s, but all the EPR valves from Sporlan as well. And this kind of just talks about how capacity versus pressure drop is related. So, as far as setting the valves, so obviously, let the caseload pull down to the desired coil temperature and then set the valve to the desired pressure setting. Again, I will send you guys a list of all how much pressure changes by each turn. It varies. So the sport valves have a certain amount of pressure change per turn. And then as you get to the high side valves, that change, the change in pressure setting is a lot greater in the high side valve since there's 2 springs inside there. But I can send that to you guys as well, so you have it as well. And then once you have the desired setting set, make sure you put you lock down the adjusting nut with the lock nut. So, all right. So I went over the EPR valves. Any questions on the sports or the sport 2s? You guys are a quiet bunch. All right.
Eric, it's Mike. Just a question on crossing them to Sporlins for service reasons. So if you wanted to replace a pie valve, an old Sporlin pie valve, would you have equivalent capacity tables for that, or the CV values that can be matched up, or should it be reselected based on the application?
I have CV tables. I'm not sure if we have cross references between the sort pies and the sport valves. I'd have to double check, but we at least have the CV tables. I know that. I mean, obviously it's not going to be a 1-to-1 match. So you obviously always want to double check and resize them. That's the best thing to do, I would say. But we at the very least have the CV tables. But I'd have to double check to see if we have the sorts and the sport cross reference. So,
Thank you.
yep.
Eric, where would we be at this point with tables that reflect the 404A, 407A, 407F, R44A, and R449A refrigerants?
That is one thing we need to have updated. Our applications team actually sent out an email to myself and several others last week with a list of all of our bulletins we have for RS and what our top bulletins we wanted updated. So one of them was the 611H catalog to update with newer refrigerants. So we definitely need to do that. The old Sporlin sizing program does have the Flowcon valves in it. So the SVD 5.09 sizing program has it in there. I'd have to double check. I have not played around with Virtual Engineer too much. I'd have to double check if Sporlin Virtual Engineer has Flowcon in there. I know there was talks of adding it to it. And then also we have a new valve selection program, VSP, for the industrial side as well. All right, so the next thing we're going to cover is head pressure controls. So this is where you would use your high side A8 valves as your liquid hold or your condenser holdback valve, and then you either use an A9 outlet regulating valve or an A8 OE as the condenser bypass outlet regulating valve. So very similar to the sport valves. The sport valves are based off the A8 platform as well. Really, the only main differences are the A8 valves have 3 different body sizes instead of 2 for sports. The A8s are not offered in the aluminum bronze configuration because they're not in the suction line, so they don't sweat as much. And then also they have higher spring range than the sport valves do. But again, they're very similar. They consist of 4 different components: the body, the capacity cartridge, the adapter assembly, and the bonnet assembly.
Eric, if I may interject there, also for the hot gas bypass, the A8L is used in floating head pressure because of the differential function as well, guys.
Yep. And we're seeing more differential valves being sold over the years recently too. So again, just setting the A8 inlet. So the A8, there's 3 different body sizes. Like I said, and I'll get into this in a second, but there's the A8A, which is the smallest, the A8-1, which is the middle size valve, and the A8-2, which is the largest valve. So you always want to set your liquid holdback or your condenser holdback valve first. And then after that, make sure you set your condenser bypass or your receiver pressurization valve after you set your condenser holdback valve. And then real quickly, we're going to jump back to the A8s, but their large solenoid valves are also based off of the A8 platform. So you got your SC1 and SC2 suction style valves. And then you also have your S81 and S82 high side solenoid valves. So basically it's similar to the A8 pressure regulating valves. You've got a body, capacity cartridge, and instead of like a bonnet and adapter assembly, you got the coil assembly on top. But it very similar. The capacity cartridges are very similar. The body is very similar, but it's a solenoid valve instead of a pressure regulating valve. Real quick, just going through the features of the SCs and the S8s. The SCs obviously are designed for the suction side applications. MOPD is 300 PSID. Because it's used for the suction side, it's offered in both ductile iron bodies and aluminum bronze. Class F coils, and then it's the same solenoid coil operator as all the Flowcon products. And then on the S8, the high side solenoid valves, is designed for high side applications. It's not available in the aluminum bronze because it's used on high side, and it's available for the ductile iron bodies. And so these come with the Class H coils rated for the higher temperatures. Some Flowcon do's and don'ts. Let's see here. Guess never use SC or S8 capacity cartridges in sport. So the capacity cartridges, they look similar. So right here, they aren't exactly the same. So make sure they're not interchangeable. Again, never use sport coils on the AA discharge valves. So they don't use, the Class F coils and the high side valves. Never use a sport valve, which is your EPR valve. Never use that for high side control. It's not rated for it. The pressure range of a sport valve is 0 to 120 pounds, whereas the high side, it goes up to 400 pounds of control. So never use a sport valve on the high side of the system. And then never use an O-ring on the diaphragm follower of an A8L, which I'll show you why. On the A8Ls, that's where the refrigerant bleeds up into the actual bonnet assembly of the valve, and so you don't use an O-ring on that application. And then quickly on the A9s, so the A9s we have the A8 valves that are outlet regulating valves. So the A8 AOE valve, that's an outlet regulating valve, and then typically for like hot gas applications or smaller systems for receiver pressurization, you don't need a big A8 valve for the bypass feature of that. So we do offer the A9 outlet regulating hot gas valve. It's a smaller bodied valve. It doesn't have, it's only an outlet regulating valve. So it only has 3 components. It has the body, the capacity cartridge. It does not have an adapter assembly because again, it only does one function. It does outlet regulating. And then you've got your bonnet assembly right here as well. So there are a lot smaller capacities. So if you compare like an A8-9 or an A9 with the 7/8 port size, the A9 7/8 port size has less capacity than an A8 7/8 port size. And again, like I said, first, whenever you're doing high side head pressure controls, first you set the A8 condenser holdback valve that's in the liquid line. And after you do so, you set the A9 valve for receiver pressurization. And then we do offer, so you got the A9 valve, just a straight up A9 valve. And then you've got the A9 SE valve, which has got an electric shutoff feature, and it's got an external equalizer as well. So the A9 SE is this one where you have electric shutoff features built into it. Here just shows you hot gas bypass, how it's piped in. I assume Mike's gone over in the past years on the different ways to pipe hot gas bypass. We know whether it gets piped into the downstream of the expansion valve between the evaporator, or if you pipe it into the suction line downstream of the evaporator, or if you use a desuperating valve and pipe it into the compressor inlet. So same with this one, you can pipe it in several different ways, but this shows piping it into the outlet of the expansion valve for hot gas bypass. And then here's, like I said, this is the second solution. You can pipe the hot gas bypass into the outlet of the evaporator, downstream of the bulb, and then you pipe the equalizer line in downstream of here. Or I guess this doesn't show the Sporlan talks. I'll show the 3 different types of hot gas bypass piping scenarios. All right, so that was the A9s, and then jumping into the differential valves. So this is this shows right here, this is our biggest valve. It's the A8-2 valve. There's 3 different, like I said, there's 3 different body sizes of the A8s. You got the A8A, which is 3/8, 5/8, and 7/8 port size. You got the A81s, which is 1 1/8, 1 3/8 port size. And then you got the A82s, which is our 1 5/8, 2 1, and 2 5/8 port sizes. So you got 3 different body sizes on the high side A8 valves. The L stands for differential, and then the B stands for the bypass feature, so wide open feature. So the difference you can tell here is it's a different bonnet assembly. So it's got the outlet pressure connection so that it can sense differential valve. It's sensing inlet pressure as well as outlet pressure. So it's sensing the differential between the two. Like I said on that a couple slides ago, there is no O-ring right here on the diaphragm carrier. That's one of the differences between this bonnet and the bonnets that are used for inlet and outlet regulating valves. Other than that, I mean, it's your standard body size, standard body, capacity cartridge, adapter assembly setup, and then a bonnet. So it still has the same four main components that the A8 valves have and the sport valves have. And then again, since it's on the high side of the system, it uses a class H coil. Let's see here. Again, this just goes through how to set the A8 differential pressure regulating valves. Set the system with no systems and defrost. I think the Sporlan talks always say to make sure you have at least 75% of your system not defrost when you're setting the valves. De-energize the coil so it's in modulation mode, so it's not in bypass mode. Set the valve for whatever differential you need, and then you're off and running. So here is the nomenclature for the A8s. So very similar to the sport valves, although there's a lot of different adapter functionalities in the sports. The sports are only inlet regulating valves. So in the sport valve, you either got the port, the sport, or the sport B. On the A8 side, you've got a lot of different options. Again, you got the three family sizes. The A8A is 3/8, 5/8, and 7/8 port size. A8-1 is 1" and 3/8 port size, and the A8-2 is the 5", 2 1/8, and 2 5/8 port size. And then after that, after the body size, you list the optional adapter assembly features. So if you have nothing in there, it's just a straight up inlet regulating valve with no other features. If you have an A8AS, that means that you've got the inlet regulator with electric shutoff. The B stands for the bypass feature, so the wide open feature. So you could have an A8AB valve. The L stands for differential. So you could have an A8AL, or if you want the bypass feature added on, you could have the A8ABL. And then you get into the two outlet options. You got the A8OE feature, which is the outlet regulating, and you got the OES, which is the outlet regulating valve with the electric shutoff feature. And then again, it's similar to the sport valves, although I don't know why they did this on the high side. I guess probably to differentiate between sport and A8s. On the sport, you list it out by how many eighths of an inch it is. So on the sport, it'd be like a sport 7/9 for 7/8 port and 9/8 connection. But here on the high side A8s, you actually list it out in the fractions. So 7/8 port size, inch and 1 connection size. Like I said, on the inlet regulating valves, unlike the sport valves are 0 to 120 pound range. For the A8 high side valves, it's 0 to 400 pound range. The differential valves go from 0 to 120 pound range. And then the outlet valves go from 0 to 90 pounds for the A8 valves. Here's just some information on bolt torque specs. And then also this is what I was talking about before on the set points. So on the sport valves, for every turn, you change the setting by 20 pounds. And then on the high side valves, on the differential valves, for every turn, you have 20 pounds. And then on the high side A8As and A8OEs, you have, here, I'll show you. Let me see, I think jump back here real quick to the A8. Sorry. So here's a picture of the A8 high side valve. If you remember, the sport valve only had one spring in here. Well, the A8 high side valve has 2 springs. So when you first adjust this thing down, the inner spring is actually stiffer than the outer spring. So when you first start adjusting down, you first engage the outer spring, and that outer spring is the same spring that's used in the sport valves. And so you have a 20 pound change per turn initially whenever you first engage that outer spring. And then once you engage the inner spring, skip back to this slide here. So one turns 20 pounds on those A8 valves until you get to 90 pounds. Once you get to 90 pounds, you then engage that inner spring and you go from one turn being 20 pounds to one turn being 70 pounds. And that applies from 90 pounds up to 400 pound adjustment. And that's both for the A8 inlet regulating valves and the outlet regulating valves as well. So, and again, the differential valves use the same spring, same larger diameter spring that the sport valves use, and which is the same outer spring as the A8 valves. So again, those have 20-pound adjustment per turn. Any questions on this slide at all? Nope. Here is one thing. So typically whenever I used to do this training on the wholesale side in the Chicago area, we do some hands-on training, and we could even do this, in the future as well. We would do hands-on training with contractors where at the end of the presentation, we'd actually have, 6 or 8 different sport valves or A8 valves, and we'd do change things on them to make them not work properly, and then we put them in a jig and actually test them. And so one of the things is if you have the jam nut too tight, the parabolic plug and the plunger will not move up and down freely. So what you need to do with this jam nut on this parabolic plug on the cartridge assembly is you need to tighten it until it stops and then back it off 1/4 turn. So if you ever experience a valve that's sticking, that could be the cause of it. This is the jam nut's too tight on it. Let's see here. This is just a product. This is an old product bulletin update. This probably, you won't come across this too much anymore. I think this came out maybe 10 years ago on the larger differential valves. So the ones that utilize the A8 two bodies, which is the engine 5 port, the 2-in-1 port, and the 2 5/8 port. Because of the loading, the side loading on the cartridge assemblies, back in the day, we were seeing that there was accelerated wear on the cartridge assembly. And so we added, I'd say maybe 10 years ago, maybe more, we added these wear rings to the cartridge assembly. So if you come across an old valve in the field, you might see that the capacity cartridge does not have those wear rings, but since then we've added these wear rings to the valves. So,
that was 2006, 2007, Eric.
Okay, all right. You got a lot more history than I do on this product line. So, like I said, I came over the RS side, over the dark side in 2017. So, let's see here. This is just basically a supermarket drawing. We had these on the Sporlan side as well, showing the Sporlan valves. And then this is a supermarket drawing on for the RS side, showing the port valves, the sport valves, the differential valves right here, high side regulating valves. So one of the things definitely we can get you guys any type of literature you need. I think one of the things we need to work on more is coming out with one of the things Jerry Wallach and I were actually tossing around. I don't know if you guys have worked with Jerry. He's my counterpart on the aftermarket side for Sporlan, is working on a countermats for Flowcon product as well. So we have all this stuff for the Sporlan side on countermats and other literatures. That's some of the things we need to continue to work on the RS side, is get more literature out there. But if you need any literature, feel free to reach out to Mike or myself or Jeff Teplin or Juanita Gutierrez as well. Other than that, do you guys have any questions at all? That was most of the presentation. I do have a couple of slides. I don't know if you are aware, we did launch, and honestly, it probably wasn't as successful as we thought it would be, but we did launch the A8 to CDS conversion kits a number of years ago. We did this originally because Walmart had a bunch of Flowcon valves on their racks, and they were building all their new stores with CDS valves. So they wanted a way to convert all the old stores from the Flowcon valves to the CDS valves. And so we created the sports to CDS conversion kit, which, I mean, we sold a good number of them, but they weren't as widely as successful as we thought they were. And honestly, to be honest, we thought that once Sportland came out the CDS valves, we'd see a trailing off of Flowcon sales for suction line applications. But we've actually seen an increase recently at the OEM side over the last 5 or 7 years. We've actually seen increase in business on the Flowcon side, surprisingly. So here's just a quick snapshot of the A8 to CDS conversion. Basically, you pop off the bonnet, the adapter assembly, the cartridge assembly, and the CDS conversion kit just bolts right to the sport body. So it's very easily assembled. You got the sport valves, the A8As, the A81s, and the A82s covered. So with that said, that's all I had as far as formal presentations. Any questions? I see there's 2 notes in the chat box. Let me,
Actually, while you're looking at those, Eric, for you guys, the most common area where the CDS conversion kit gets looked at is on racks where they want to have a variable temperature coffin or case, and it gives them the ability through the E2 or the CDC to change the set points of those remotely.
And they're also suitable for converting high side regulators too, correct, Eric?
Yep, that's what we're showing right here is the A8As, 1s and 2s, as well as the sports. Yep, you're correct. So that's actually where we've seen it probably more applied is on the high side when people want to go to electronic head pressure controls. They've replaced they've converted the Flowcon valves to the CDS valves. So,
and a question on the components themselves. The label that would be on the valve would show A8A, OE, and that nomenclature. Are the 4 components that make up the valve marked individually so you can identify them if that label is compromised?
that is a good question. I believe the capacity cartridge has the size noted in there. Good question, Mike.
Actually, Eric, unless that's changed, the cartridge does not. The only place it is noted is a stamping on the end of the parabolic plug.
Okay. Yeah, that's probably something we'd want to look at in the future. I should probably challenge engineering manufacturing and find out why we've never done that before.
Yeah. It would be very good to have it on the outside of the cartridge because quite often, and the guys on this call can tell you, they've spoken to supermarket guys and they don't know the port size of the valve because it's unintelligible on the red and white label.
Yeah. No, good question. Good question. Yeah, it's definitely something I'll take back to engineering after this call and find out why we can't get that stamped.
Thank you.
Yep. Any other questions on the presentation? If not, I was going to then just jump into the 2 main catalogs that we use. No? All right. Let me, all right. So let's open up all right. So Jeff, you said you sent this out to everybody on the call already, these catalogs?
Yes. Has anybody not received a copy of it? Please let me know via email. You should have this copy of the 611H as well as the PKR 03 catalog.
So this catalog, it's solely geared towards the Flowcon product line. You know, first several pages just have descriptions of the different valves, different applications. It first gets into sport valves. I'm sorry. Again, this is where you can find all the different features and benefits, the specifications of the valves, the pressure ratings, temperature ratings, and then it goes into the actual nomenclature of the valve, which we already covered. Again, like I said, the difference between the A8s and the sports is the sports always list they list it not in the fractions of an eighth of an inch. They just list the number of eighths of an inches. So 7/11. Whereas if you look at the A8 valves, it'd be 7/8 inch and 3/8. Here's all the different combinations of this. So on the smaller body size, like I said, there's two body sizes for sports. The smaller body size goes up an inch and 3/8 port size. But you can mix and match all the connection sizes. So for instance, on all of these, you can actually go up to 2 1/8 connection size with that body size. So even though you only have, say, an inch and an eighth port size, you have all of these different options as far as connection sizes. And that's for the sports and the sport twos. And then the larger body size of sports, you can go up to 2 5/8 connection size and port size. So just running through this real quick, some technical information, and then you start getting into all the capacity tables. Like Jeff asked, when we're going to update this with the newer refrigerants. Like I said, that was one of my votes. One of my main votes to update was this catalog, for our advertising department to work on focusing on updating that. But you can access the other refrigerants through the different sizing programs. Basically on the sport valve sizing, for the suction capacities, it breaks it down based on port size here in these columns. And then it breaks it down based on evap temperature that you're controlling and the pressure across the valves as well. So we typically say we'd like to see a 2-pound pressure drop across the valves. A lot of people will apply it at a 1-pound pressure drop across the valve. The only problem is whenever you oversize a sword valve or a sport valve and a sword valve for that matter, you'll sometimes get whistling. So you'll have in the supermarkets, you'll hear, whistling because that valve is just barely cracked off the seat. So in those cases, the valves could be oversized. So that's one thing I'd be mindful of is just, make sure you don't oversize the valves.
Actually, Eric, the other thing to note in a grocery store is the reason we show the 1, 3, 5, and 10-pound pressure drop is depending on the temperature of the case, you could see a house suction, which is your main suction back to the rack, that it's easily 5 or 10 PSI below what a warmer case may be being run at. And if you take a look at the variance in capacity from your 1-pound through your 10-pound pressure drop, you can quite easily, as Eric indicates, if you had a higher pressure drop to a low house suction, end up in that valve being oversized. And that whistling that he speaks of does happen and can create really annoying harmonics in the store that the end user gets kind of upset about.
You guys can see this main screen, right?
Yes.
Okay. Yeah, for some reason it's not, usually Zoom will have like a border around what you're showing. So I just want to make sure you guys can see my screen. Yeah, and to Jeff's point also, if you use like the old Sporlan sizing program as well, it'll show you what we call the available pressure drop, which is basically the difference between what you're controlling your evaporator to and what your common suction is. And so, yeah, to Jeff's point, it could be 3, 5, 10, 15-pound differential between what your common suction is and what you're controlling your evaporator to. So in that case, I mean, if you are controlling a medium temp case off of a low temp rack, you could get by with a smaller valve that has a higher pressure drop.
And if you're using the virtual engineer for sizing a valve, it's going to ask you for 2 values that have to do with your suction. One is going to be your evaporator temperature, and the second is going to be your suction temperature. So you will need to know those 2 values, plus the superheat back to the compressor for sizing an EPR properly, whether it be a Sporlan or a Flowcon. It asks for those pieces of information.
And Bob just asked, can you still get the old Sporlan sizing program? It's not available online anymore. Mike, you probably have some old CD-ROMs sitting around. I know I think I have the executable file that I've sent to people in the past, for them to load it on their computers. I've sent flash drives before with the old program. There's no formal location that I think it's available to the general public anymore, but
Correct. And it hasn't been updated either. So it's lacking in new product.
correct.
But it is that's the only, if you've got one, keep it somehow. And
Actually, Eric, because we've had a number of computer upgrades, there are many of our staff that have lost access to that 5.09 version. If we can get that executable file so that we can load it where it would be desirable, that would be very helpful.
Okay, absolutely. Yeah, I'll take a look to see if I still have that separate executable file. Mike, I don't know if you have it at all. I have CD-ROM. I have old CDs of it, but I don't have a CD drive anymore on my computer.
yeah, I don't have a NIST version. I've got the one we gave away with the ed packs, but not a NIST. There's a lot of CO2 up our way, and so having the NIST version is a requirement. So if you've got something like that or can get your hands on it, that's what we
I'll
need.
see if I can get the NIST file or the NIST version. The one I have on my computer right now is not the NIST version. So. I'm just going down this again. Suction capacities, just different refrigerants and kilowatts and tons. Kind of skip over.
Eric, just a question on sizing for EPRs. Oversizing can lead to control difficulties, correct? Like modulation problems?
Oh yeah, absolutely. I mean, you're trying to control
Yeah.
very little flow with a huge port.
Right. So sizing they're not that forgivable if it's oversized or undersized in that sense.
Yep. Yeah, and that's why we recommend 2 pound pressure drop across the valve, but a lot of people do apply it at a 1 pound pressure drop. But yeah, I mean, once you get below that, then you're going to definitely have control issues. Same with the SORT PI valves. The SORT valves, because it's powered by high side hot gas, it's a little more forgivable, and those can be applied down to a 0.5 pound pressure drop. And then below that, that's why a lot of people like the CDS electronic EPR valves, because you can apply those things down to 0.1 pound pressure drop if you need to. So.
Right.
Eric, this is Glenn in Kelowna. I just question if you do have that turkey case scenario where you've got dual temperature coffin or whatever you're running medium temp, the selection is going to be that much more critical, I'd assume, as your pressure drop increases and the sizing of the valve capacity changes.
Yep, and yeah, and you obviously always want to, whenever you're sizing the valves for different applications, different scenarios, different conditions, you want to size it based on the 2 extremes. Not just EPR valves, but anytime you're sizing expansion valves, like Mike, I don't know if you've sent any of the information to them on what Jerry's put together as far as the AWEF condensing applications where, when they're floating high side pressures, and you have to make sure you size all of your valves, whether it's your expansion valves or EPR valves, based on the worst extreme cases, so that you make sure that valve covers all those applications.
Actually, Eric, we've had extensive conversations on this subject internally to do with the AWEF issues. Yes.
And Mike, has Jerry sent that formally out to all the distributors?
We've shared it. Mackenzie shared it with Jeff. And
okay, good.
Both of them exists. Yeah. But again, like Jeff alluded to, or I'll expand on it in case you all haven't seen it. It's more of a quick pick table. What your practice is now is basically adopted what Eric said. You check it at the high, you check it at the low, you're going to get the valves that you require. This quick pick table just kind of, if you've got limited information, it will provide you with a workable selection for an expansion valve to comply with the AWEF requirements. If anybody's looking for that, you can contact me and I'll get it out to you. It is posted online as well on sporlon.com.
Actually, all sales got that about a month ago when Mackenzie gave it to me.
Great. Thank you.
All right, just going through the catalog, you got your high side pressure regulating valves, so your A8s, and again, just has all the features and benefits, the specs, the nomenclature. We've already gone through all this, so I'm not going to go through this anymore. Has your has your port size and your connections available, the combinations that are available here. A little more limited as far as the wide range. So on the sport valves, you could actually get a 3/8 port size with a 2 1/8 connection size if you needed to. But because the A8s are divided into 3 body sizes instead of 2, you don't have as much wide range of options. But you still can get, a 3/8 port size with a 1/8 connection size if you needed to, or a 5/8 with a 2 1/8 connection size. There's a lot of different combinations there. Just a lot of technical information. If you guys are bored and want to fall asleep easily at night, feel free to read through this stuff. Here's the A9 product range. So again, it goes through the features and benefits, the specs, the nomenclature, the port size applications. Again, like I said, the port sizes of the A9s versus the A8s. Don't think an A9 7/8 is the same thing as an A8 7/8. The capacities are a lot smaller on the A9 valves. So if you're in a pinch and if you're replacing an A8 7/8 and you don't have an A8 7/8, do not just automatically think the A9 7/8 will replace it. It's a lot smaller. So make sure you resize if you're using an A9. It's got the CK4 check valves here. Just features and benefits of the CK4As in here. Capacities of these check valves as well. Just flying through here real quick. So I already showed you the capacities, the suction capacities for the sport valves. Here's where you start getting into the liquid capacities of the A8 valve. So liquid meaning you're using this as a condenser holdback valve in the liquid line. So that's why you see the capacities jump up so much. These are the same size ports as the sport valves, but because it's used in liquid capacity applications, it's a lot higher capacities. So again, just have different refrigerants and different tons and kilowatts. See, stop me if you have any questions on any of this. Here's the discharge capacities. So you got suction, liquid, and discharge capacities for all the A8 valves, the different refrigerants. And again, these are all at different pressure ratings as well. So, you got 3 pounds and 6 pounds listed. So obviously the sizing program will dive a little more into detail between these two, but if you can obviously extrapolate or interpolate if you need to come up with the capacities between these two or outside of these two pressure ranges.
Most commonly, you'll see these tables being used for the 82BL selections.
Yep. Sorry, just skipping through this real quick. Trying to see if there's anything else I wanted to show you other than the capacity tables.
Just while you're doing that, for the defrost differential valves, one of the things to always verify with the contractor is the location of the valve, because depending on how you're sizing it, you may need to use the liquid tables or the discharge tables. So just again, matching the valve part number up is a direct replacement. But if you were trying to do a conversion from an old Sporlan valve or some other manufacturer's regulator, knowing where that regulator is installed is a key question.
Yeah, and the two styles that Mike is alluding to there are, you've got a holdback valve in your discharge main that is holding back pressure so that the hot gas defrost has enough gas being pushed out to the case or evaporator. And then you may have a liquid line differential valve that allows the condensate that's produced through defrost to be pushed back into the liquid line. So there are two very different cases for that selection.
Those cross over on the Sporlan side. It's the LDRs, the liquid differential regulators, and then the DDRs, which is the discharge differential regulators. And then here I'm showing is the condenser bypass capacities. This is where you're bypassing, discharge refrigerant from the compressor around the condenser into the receiver to pressurize the receiver. So again, those are outlet regulating valves. You either use the A8 OE valves or the smaller A9 valves. So this has condenser bypass capacities. And like I said, so let's just compare. So an A9 7/8 right here in the first line, 28 tons of capacity compared to an A8 7/8, almost double the capacity. So if you're trying to swap between A8s and A9s, make sure you resize because they're not even close to being identical as far as capacities. Again, just all the different tables for all the refrigerants, both in tons and kilowatts. And then gets into hot gas bypass. So there's these outlet regulating valves, again, can be used in hot gas bypass applications, hot gas to the low side of the system. So again, you got A8 OE outlet regulating valves and A9 valves that can both be used in this application. And you size based on condensing temperature, discharge temperature, and then the capacity of the how much you're trying to bypass. And again,
Eric, can you scroll back up just a little bit to show the diagrams as well?
Oh,
These
yeah.
are a great resource to send to a customer to try and differentiate what you're truly working with.
Yeah, here's actually, let me pull up, I'm sure you guys have all seen the Sporlan one, but there's a Sporlan, what is it, 90-50? Mike, you probably know it better than I do off the top of your head. I think it's 90-50.
Sorry, Eric, what do you?
I was pulling up the Sporlan,
Oh, okay.
discharge regulator. Oh, that's a differential. Hold on. Is it 90-30 then?
60. Oh, 40. You're right. Yeah.
There it is. So in the Sporlan 90-40 bulletin, you've got, so the RS bulletin showed you two applications for hot gas bypass. You got the first one where you're going from your compressor discharge to the outlet of your expansion valve using an auxiliary side connector before your evaporator. And then your second application could be where you're pulling hot gas off your compressor discharge and piping it into the into the suction line downstream of the right downstream of the evaporator, basically. So your expansion valve is sensing that hot gas coming in here, and your expansion valve's reacting to that hot gas being dumped into the beginning of the suction line. And so those two applications are shown in the Flowcon bulletin. And then the third one is not shown in the Flowcon bulletin, which is where you have hot gas coming off your compressor outlet, and instead of piping into your auxiliary side connector or into the beginning of your suction line, say it's, say your evaporator is 300 feet from your compressor, you don't want to run a 300-foot line for hot gas bypass. You can then dump it basically right back into the suction line near the inlet of your compressor. But because you're doing that, and because it's downstream of your main expansion valve bulb, you need to have what's called a desuperheating expansion valve pulling off the main liquid line and then basically bullheading. So you got your hot gas coming out of your hot gas bypass line and your desuperheating expansion valve coming together, mixing cold liquid vapor with hot gas and then dumping it in the suction line. So those are, so to Jeff's point, you can either get those diagrams here. They have two of the three applications I just showed, or the third application is shown here in bulletin 90-40. So, all right. Any questions about that?
I'll just add, those would be Sporlan expansion valves, and they would be special desuperheating charges that we've talked with, typically an L1 or an L2 thermostatic charge. So that's a Q-bench part, hopefully.
I'm trying to see what else is there that's pertinent to talk about here. Crankcase pressure regulating valves, again, those are just, outlet regulating valves used in the suction line to limit the compressor inlet pressure. My former job, whenever I used to work at a chiller manufacturer called Thermalcare, we used to build a lot of chillers for higher temperature applications, laser and optics cooling. And so we'd be typically running, an evap temperature of around 80 degrees, 70 to 80 degrees. We're cooling lasers and optics. And so it was running way too high of pressure to go into the compressor. It would overload the compressor. So on most of our chillers, we'd have crankcase pressure regulating valves built into the suction line to limit the pressure going into the compressor. So that's so you can use the outlet regulating flow con valves for that application as well. And then you got your suction solenoid valves. You got your nomenclature here. Your SCs, you got two different body sizes, just like the sport valves, you got two different body sizes. And again, just like the sport valves, you talk the port size and the connection sizes are listed in the number of eighths of an inch, not in fractions. And then the SC2s are the aluminum bronze bodied ones also. And then capacity tables. And just a bunch of abbreviations down at the bottom here. Some quick reference stuff here. So we have separate bulletins. Like if you need a bulletin specifically for the A8As, we have a bulletin geared towards that, or the sport valves, we have a bulletin geared specifically towards that. I typically just use the 611H, but if you need to print off something that specifically focuses on the sports, we've got a sport bulletin. It's, I think it's 6 or 8 pages that specifically focus on that. So, but all those are listed in here. That's about all for the 611H. That's and again, this is one of the documents that I'm pushing for our advertising team to update with new refrigerants. There really hasn't been any changes. The only new valve that's been added since this last time this was updated was we came out with we used to not have an A8 two-bodied outlet regulating valve because we typically never saw the need for, somebody having that much hot gas bypass or that much receiver pressurization until we started dealing. There's a company out in Asia that builds really, really big ice machines, and they needed a very big outlet regulating harvest valve for their ice machines. And so we started building the A8 two bodies with outlet regulators. So that's really the only product that's been added to the Flowcon product family since this was last updated. That and obviously updating the refrigerants as well. So that's that. And then the parts kit bulletin, which I was really happy when they came out with this, probably, 8 years ago, maybe. When was this printed? 2012. Before that, it was a little more tedious to find the parts for each valve. But I think this is a pretty nice bulletin where it basically goes through all the major product variations. So like an A8A or an A81 inlet regulator, and it breaks it down by each part, full blown out picture of the entire valve by part with the part description, the kit description, the kit number, everything. So it goes through, all the different combinations of valves, the A81 inlet regulators, the A82 regulators, inlet, with the electric shutoff features. So this is a very good resource. And this is one of the other ones I want them to update as well. It's pretty much updated. There's some things that still need to be tweaked. There's some part numbers we've changed. Since one of the things we actually came across recently, since we combined Sporlan and RS together into one division, we came to find out that there was part numbers that we both used. So Sporlan had a 1, 2, 3, 4, 5, 6 that was say a filter dryer, and then Parker RS had a 1, 2, 3, 4, 5, 6 that might have been a diaphragm kit. And so we've had to figure out how to manage that. So there's some part numbers in the RS. So Sporlan being the bigger of the two divisions, Sporlan outrode the RS. And so RS was forced to change some of their part numbers. So there are some part numbers that we've more recently changed just because of overlap with Sporlan. So that's really the main thing that would need to be updated in this parts kit bulletin is that. But if you call, say you call in and talk to customer service and you give them a kit number that might have changed, they'll know what the new part number is. So other than that, this parts kit is basically just for each valve, all the pages are just the different valve variations with all the parts kits and all the specific individual parts that can be individually sold. So very good resource if you want to get into, if you need to look up a specific valve that customer has and what parts that they need. So any questions about the parts kit at all?
No, just a comment, Eric. So just you guys remember, I also sent out 4 attachments, which are the workshops that have a minimized common parts list selection for each of the valve types that actually Garth Dennison and I worked on when I started with RSL back in 2008. So Garth Dennison did a lot of great work on that back at that point.
And then Jeff, did you send out the CLP 21s to everybody, or is that just, does your purchasing team have that only, or does everybody have access to the list prices?
You're talking about the pricing sheets?
Yes.
That just went to purchasing.
Okay. All right. Yeah, then I won't go over that. Then I assume purchasing will handle pricing then. So, but yeah, if you have any questions, like I said, Jeff and I can resend it to you if you don't have it readily available, but the contact information for Parker, RS, 708-681-6300 is the main phone number for the Broadview facility. And that's where you can get a hold of customer service or get a hold of the application team. We have 5 different customer service people. Joan Hawthorne is the customer service manager. And then she has 4 people reporting into her. Earl Washington, who's probably the most soft-spoken person you ever talked to in your life. Yet he used to be a Gold Glove boxer back in the day. So you'll never think that he was a Gold Glove boxer back in the day when you talk to him. But and then you got Nancy Nolan, Tish, and Rosa Rallo as well. So there's 5 customer service people. Jeff Teplin is our main applications engineer. Like I said, he's been with RS for I think he just hit his 42nd year. And then Juanita Gutierrez as well on the applications team. Mike, you'll be the main contact on the sales side, obviously, and then myself as well out of Broadview. So,
And Eric, your lead time for parts kits and other components out of Mauston, what's that typically?
It's very good. So parts kits, we typically have, your diaphragm kits, your gasket kits in stock. Because we cater on the industrial side, we cater to contractors a lot that need something right away. The Mauston facility has been kind of set up where they can, unless it's a huge order for like a couple hundred valves, they can react pretty quickly, where they can ship a parts kit out same day sometimes, or if you need a couple valves, they can ship out a couple valves in 2 or 3 days. Larger orders, you're typically looking at 1 to 2 weeks, maybe 3 weeks sometimes. But we are very, very nimble. We can react pretty quickly to orders that come in. So
Thank you.
For our staff, I can speak to the fact that purchasing has found so far with the orders that the response has been 2 to 3 days and the product is shipped.
Yeah, for the most part, and the complete valves we don't typically keep in stock, but we have all the components in stock, and they can react pretty quickly and build a valve pretty quickly. It's if the only times you'll come across extended lead times are if it's a larger order. If one of our contractors in the United States has a new cold storage warehouse or processing facility, and they need 100 of the industrial valves, it might be a couple weeks. Or if Hill Phoenix or Hussman or Kaiser or Zero Zone needs 100 sport valves, it might be 2 or 3 weeks. But onesie twosies are very quick. So,
And sorry, another question. Sorry. is you do not have a solenoid for liquid line use or discharge use. It's just for suction.
The S8. Let me double check to make sure that's still applicable in the liquid line. We did obsolete some of the solenoid valves in the RS side because just we weren't selling as many, and Sporland
Okay,
has
no.
most of that business. But let me look this up quick. Yeah, let me get back to you on that, Mike.
Okay, no problem. Thank you. I was just curious.
Jeff, was there what else did you want me to cover today?
I think that's pretty much covered the majority of it, Eric. That's been great. On the solenoid side, I would agree with Mike that typically we'd be going the Sporland solenoid. If you had a larger application for a larger solenoid, we'd be looking at the RS or the refrigerating specialties solenoids for those capacities. But for the commercial side, typically the Sporland. Does anybody have any other questions in regards to the products at this time, or any comments? Okay, so for you guys that are on the call, there will be some training coming up on valve modification. As Eric alluded to, these valves are very component oriented, so that when you do run into a situation where you don't have the right connection size for a application, the first thing would be to determine, is this a replacement valve where the person is doing service, or is it a new application and you actually need those fitting sizes? We will be doing the training on how to disassemble the valves safely and reassemble them with the change in the body aspect to meet the port size or the connection size that's required. That'll be coming up in the near future as a separate subject, and we will be putting together workbenches and the tools to do this work in the different locations in the very near future. And with that, Eric, I think we're good, and that's been absolutely fantastic.
All right, good deal. And yeah, once I get the file, we can figure out how to get that via Dropbox sent over to you.
That's absolutely fantastic. Much appreciated, sir.
Yeah, absolutely. And hopefully, hopefully, once this pandemic's over, I can travel up to Canada and meet with everybody, and we can do some further training as well. But yeah, feel free to lean on Mike and myself for any support you may need. So.
Not a problem. We will. And if you could just resend me the email with the contact information, in particular for Jeff and Juanita for technical support, that'd be fantastic, because Joan is really key towards the order entry aspect, not really supporting on the product side. So I want to make sure the inquiries are going in the right direction.
Yep. Yeah, that's a good point. So Jonan's extremely knowledgeable, both on order entry side as well as product side.
Definitely.
But yeah, she typically does not field like application issues or technical questions just because she's too overwhelmed with the customer service side of it. So I would direct that to Jeff or Juanita, or on the sales side, Mike or myself. So, but yep, I will send that over to you. So
fantastic. Thank you.
All right. Well, thanks everybody for your time today, and I'll talk to everybody soon.
Okay. Thanks, everyone. Thanks.
All right. Take care.
Thanks for being here, Mike.